Welcome to Star Chat, the podcast that takes you on a journey through the vast expanse of our universe, exploring the wonders that lie beyond our planet. I'm your host, Carl, and I'm thrilled to have you join me on this cosmic adventure. As we begin today's show, let's take a moment to appreciate the sheer scale of the universe we inhabit. With billions of galaxies, each containing billions of stars, the possibilities for discovery are endless. And speaking of discoveries, we have a fascinating story to share with you today. Imagine a star system, not so different from our own, but with two suns instead of one. A binary star system, where two stars dance around each other in a gravitational waltz. Now, imagine a planet, a young and massive world, orbiting one of these stars. This is the story of HD 135-344 AB. A remarkable exoplanet that's caught the attention of astronomers. Located about 440 light-years from Earth, HD 135,344 AB is a gas giant, similar to Jupiter, but much younger. It orbits one of the two stars in the binary system, which is itself a fascinating object of study. The other star, still surrounded by its protoplanetary disk, offers a unique glimpse into the early stages of planetary formation. The discovery of HD 135,344 AB was made possible by the powerful sphere instrument on the Very Large Telescope in Chile. By combining the light from all four telescopes that make up the VLT, astronomers were able to detect the faint signal from the planet and confirm its existence. But what's truly remarkable about this discovery is that it shows us how planetary formation can occur at different rates for each star in a binary system. Think of it like two separate construction sites where the building blocks of planets are being assembled at different speeds. While one star has already formed a planet, the other is still in the process of gathering material from its disk. This raises intriguing questions about the potential for life on such planets and how they might evolve over time. As we continue to explore the universe, discoveries like HD 135,344 AB remind us of the awe-inspiring complexity and diversity of celestial systems out there. And with new telescopes like the Extremely Large Telescope being built, we can expect even more exciting revelations about the nature of our cosmos. We'll be right back with more fascinating space news on Star Chat. Welcome back to Star Chat. I'm your host, Carl. We're exploring the vast expanse of space news and discoveries today, and we've got a fascinating story to share with you in this segment. As we delve into the intricacies of space policy and technology, let's take a journey to the forefront of human spaceflight and the vehicles that are taking us there. In the realm of space exploration, few endeavors are as ambitious as NASA's Artemis program, aiming to return humans to the lunar surface by the mid-2020s. A crucial component of this mission is the Space Launch System, a powerful rocket designed to carry astronauts and cargo on deep space missions. However, the development and funding of SLS have been subjects of intense debate and scrutiny. Recently, the House Appropriations Committee released its draft budget for NASA, which includes significant funding for the SLS program. The proposed budget allocates $2.5 billion for the Space Launch System, close to this year's funding level and $500 million more than the Trump administration's request. This move is seen as a vote of confidence in the SLS program, despite earlier proposals to cancel it. But what's really interesting here is the mention of an alternative upper stage for the SLS rocket. The current design, known as the Exploration Upper Stage, is facing challenges and delays. In response, lawmakers are suggesting that NASA consider using existing upper stages from other rockets, such as United Launch Alliance's Centaur V, or even Blue Origin's New Glenn second stage. Now, you might be wondering why this matters. The answer lies in the performance and capabilities of these different upper stages. The U.S. is designed to provide the necessary oomph for SLS to carry heavy payloads, including the Orion crew capsule and equipment for NASA's Lunar Gateway space station, on a single flight. However, if alternative upper stages can offer similar or even better performance, it could potentially save NASA hundreds of millions of dollars in development costs. As we navigate the complex landscape of space policy and technology, it's clear that compromise and innovation will be key to achieving our goals in space exploration. The possibility of flying the Centaur V upper stage on SLS missions is an intriguing one, offering a potential shortcut to getting the Artemis program back on track. But for now, the fate of the SLS program and its funding remains uncertain, as lawmakers continue to debate and negotiate the details of the budget. One thing is certain, though. The next few months will be crucial in determining the future of human spaceflight and the role that NASA's Space Launch System will play in it. Stay tuned for our final story of the day, right here on Star Chat. Welcome back to Star Chat, folks. I'm your host, Carl, and we're glad you're joining us again as we explore the wonders of the universe. Today we've been talking about some fascinating topics, from distant galaxies to the latest advancements in space technology. But for our closing segment, let's take a closer look at something that's happening right here on our home planet. Or rather, with our home planet itself. You see, Earth is spinning, and it's doing so at a rate that's not always constant. In fact, over the past few years, our planet has been spinning faster than usual, resulting in some remarkably short days. And by short, I mean really short. We're talking about days that are milliseconds shorter than average. Now, you might be wondering what's causing this phenomenon, and whether it's something we should be concerned about. Well, according to scientists, the reason behind Earth's rapid spin is still not fully understood, but there are several theories. One possibility is that it's related to the movement of our planet's core, which could be affecting the length of a day. Another theory suggests that changes in the atmosphere or the oceans might also play a role. Now, here's where things get really interesting. If Earth continues to spin at this rapid rate, it could potentially lead to something called a negative leap second. That's right, folks. Instead of adding an extra second to our clocks to keep them in sync with the planet's rotation, we might actually need to subtract one. It sounds like science fiction, but it's a real possibility that scientists are taking seriously. In fact, some experts predict that this could happen as early as 2029, although others think it might not occur until later. But what does this mean for us? Well, in practical terms, it's unlikely to have a significant impact on our daily lives. However, it could affect things like GPS technology and other systems that rely on precise timing. As we wrap up today's show, I want to leave you with a sense of wonder at the complexities and mysteries of our universe. From the spinning of our planet to the dance of distant stars, there's always something new to discover and explore. So, keep looking up at those stars, folks. You never know what secrets they might hold. That's all for today's Star Chat. Remember to like, share, and subscribe. And until next time, remember to keep looking up at the stars.